Okay, welcome back to CSE 1322. This is module number 3, part 4, and in today's lecture we're going to talk about interfaces. Interfaces are very similar to what we spoke about in the last lecture where we talked about abstract classes. But in today's version, when we're dealing with interfaces, the main rule is that interfaces can no longer have any concrete methods. So if we think about this from the 3 classes that we've seen, we have concrete classes, which is every class that you had ever written before we got to this section where we started talking about abstract classes and interfaces. Everything you'd ever written was a concrete class. And so one example of a class is that it has all concrete classes. Another example of a class is the other extreme of this, which is what we're calling interfaces. In this case, it is all abstract methods. I meant to say methods here, not class, sorry. So all concrete methods in a concrete class, all abstract methods in an interface. And you might wonder, well, where does that put abstract classes? The answer is they're somewhere in the middle. But what's interesting is that this has to be all the way at this end. In order to instantiate a class and actually make an object, it has to have all concrete methods. That is a rule. And on the other side, this one is also a rule. In order to make an interface, everything has to be an abstract method. You cannot have any concrete methods. So that means that this middle ground, the abstract class, can be anywhere in between the two. When we talked about abstract classes, we said it can have abstract methods. It doesn't have to have them, but it certainly can have them. If you were to write an abstract class that had all concrete methods, it will be on this end. It's the same as a concrete class, except you can't instantiate it. If you were to write an abstract class where all the methods turned out to be abstract, then it's the same as an interface, for the most part. Or you can have it be somewhere in the middle where you've got a mixture of the two. You've got some abstract and you've got some concrete. So it's important to remember this as you're looking at classes. We have concrete classes, we have abstract classes, we have interfaces, and I want you to think about them as if they're on a continuum like this, where you can be anywhere in between. All right, so first thing to do is to talk about a real-world example, and then we're going to talk about an old problem from object-oriented that we had in the past. So in order to succeed in this class, we've told you that you need to have a computer. Obviously, you would not be able to write the labs or the assignments if you don't have a computer. Okay, you could technically come in and use the labs in college, but it's going to be tiring to do that. So really, to succeed here, you need to have a computer. To put this in the most nerdy terms that we possibly could, effectively what we're telling you is you need to have access to a computer. The details of what you need to have access to, that's up to you, but there has to be a computer. And so if you wrote this down as an interface, it would look something like this. You would say interface, have access to computer, public void, it needs to be able to run an IDE, it must have a webcam, and it must be able to print, because sometimes you're going to need to be able to print, I guess, I don't know. So each of these are requirements, and you'll notice that these are abstract methods. They're abstract because there's nothing in between here and here. If they were concrete, you'd have curly braces and you'd have a whole bunch of code in there. But since there's just a semicolon here, all 3 of these are abstract. So this interface is an interface because it's all abstract methods, as I said. And the way that you declare an interface is just the same as you declare a class. You simply start with interface, and then you give it an interface name, a set of curly braces, and then you list out all of the abstract methods that you need to have in there. Okay, so in the nerdiest terms, this is the interface that you must satisfy in order to take this class. So let's take a look at our next one. Note that when we were writing that interface, there's nothing in there that says that your computer has to be a Mac or your computer has to be a PC or a Chromebook or a tablet or a Linux machine. It just says you must satisfy those requirements. And that's the real world of how it works for interfaces. An interface doesn't give you the details of how you implement it. It simply says you must meet these requirements. And so when you write an interface, you're effectively setting up a set of requirements that anyone who implements that interface must adhere to. And so, in general, an interface is really just a set of rules that you're imposing upon any child that implements this particular interface. So if you want to say that you are in 1321 and your class is class student, then you would say class student implements have access to computer. And by virtue of the fact that you've written this implements has access to computer, you now have to have definitions for the three methods that we saw in the last slide, because all three of these have to be there in order to satisfy this. In the same way, when you had an abstract class, anything that was required in the abstract class that was abstract, any methods, had to be actually implemented in the child. So really what has happened here is that an interface is just a set of rules that you need. So you might ask, well, then why are we doing this? None of this makes sense. I am the person writing the code. So if I need to write a method, why don't I just write the method? Why would you have why would I write a set of rules that says that I will write these methods at some point in the future? That doesn't make any sense. Well, the part that you're missing is, it's not you writing the code. When you get hired at a company, you're not the only developer, and you're not going to be the one writing all of the code. Any large set of code that you are working on, which might be numbered in the hundreds of thousands of lines, is maintained by more than one person. Honestly, in most companies, it's maintained by more than one team. You're on a team that only does one part of it, and a different team does other parts, and another team does other parts, and another team does other parts. So what's the point of the interface? Well, if your manager needs to make sure that all of the classes that are, let's imagine from a video game example, all of the characters know how to walk, then you're going to make an interface on what it means to be able to walk. Walking means that you have to know how to move one foot in front of the other. It means that you have to be able to do a certain amount of balancing. It probably has rules as to how heavy of items you can carry before you're no longer allowed to walk. It probably has to have rules about how you walk up a hill versus how you walk on a flat surface versus how you climb a rock face versus how you swim or anything else. All of those are going to be rules that are written out in the interface. And then the person writing the code for walking is going to have to implement that interface. And to put it in more general terms, really there's going to be a movement interface. The movement interface is going to cover all forms of movement, whether it's walking, running, jogging, climbing, swimming, horseback riding, riding a motorcycle, whatever options there are in the game, all of them will have to adhere to the movement interface. And that guarantees that once you've written your class for how it works to swim, maybe that's what you got hired to work on, then as long as you've implemented that interface, everybody else in the company who never meets you because you work in a different city than them, everyone else in the country already knows that your class that you wrote must have all of the methods that are declared in that interface. So they know they can call those methods without ever having to talk to you and ask you what you wrote. And that's the part that's hard to understand when you're writing code here in 1321, 1322, or even in your later classes. You're the person writing the code, you're the person testing the code, and you're the person running the code. So it all feels redundant when you're being told, well, I have to write these rules. No, you're the one doing it. When we tell you you need to comment your code, you're like, why? I'm the one who wrote it. I know how to read my own code, sometimes. But in the real world, you're not the person reading it. You're not the person writing it. There's going to be somebody else who's there. Very often, your job may be to define the interface, and then you hand it to another coder who actually does the implementation. And the reason for that is that allows the company to do large amounts of stuff at once. If one person was coding, the code can only proceed at the rate at which one person can code per week, which isn't going to be very fast in the real world. Whereas if you're able to divide it up into 10 tasks, you can proceed at 10 times that speed, and you can get 10 times as much done per week. So that's why it's important that we have interfaces. They're really just a way of giving rules to the individual developers that they have to implement. Okay, so let's come back to a problem that we talked about before. And this was at the very beginning of the inheritance and object-oriented programming slide. We mentioned this example. Let's imagine that you have a class man and you have a class wolf, and they each have the ability to run. So they each implement a run. The question was, can you have a child which has two parents, each of them giving you a run method? And if that were the case, which run would you actually get? Would you get the one from this parent, or would you get the one from that parent? And the answer we said was, Java simply outlaws this and says you can't do this. And there was a little footnote up there that said, except in C++. But for the most part, most languages don't allow you to do this. This is called multiple inheritance. It means you're able to inherit from two things above you. And we said that Java doesn't allow you to do this, but then we said, sort of. There's something that we needed to tell you later, and now we're there. So this is the very specific thing. It's called the diamond of death in case you ever get this in an interview. People might ask you, what is it and why would you have it? Or why is it a thing? And the answer is, if you have two parents, it's possible that you inherit two different versions of a given method from a parent. And since you inherited two versions, it's not clear which version you would actually end up running. And so, as we said, Java doesn't allow this. This is forbidden. What Java does allow is that you can have an interface. Now, you might say, well, how does an interface fix this problem? And the answer is, all of what you have here is a conflict between this and this. There's an implementation for this run, and there's an implementation for this run. And the problem is we don't know which one this got. Well, if we simply say that this is an interface, we know that there's no implementation for this run or this run. And so in that case, this is quite happily able to inherit from both of them because it's going to have to write its own version of run. And so that's really how Java gets around this problem, is that it allows you to create interfaces. So I've said a couple of things there that I kind of glossed over. The man and the wolf, if they are both interfaces, which that doesn't really make sense in this example, but let's just go with it for a moment. Man is an interface, wolf is an interface. They both have a run method. They don't have an implementation, they just have an abstract method run that says they both know how to run. When you get to the child, you only have to implement run once. Even though there were two separate parents or two separate interfaces that require you to have a run, you actually only have to implement it once. So that's the first thing to be aware of. If you if you have multiple interfaces that you're implementing, and they each have requirements, the sum of those requirements that has been unique is what you have to implement. So if man has 15 methods that you have to implement, and wolf has 10 wolf has 10 methods that you have to implement, and man has 15. Did I say that backwards? Anyway, whatever. 25 methods that you have to implement. It doesn't matter which one you got it from, which interface you got it from, you just have to implement it. And if both of them require the same thing, you just have to implement it once. Okay, so as long as we are dealing with interfaces, interfaces allow you to have multiple parents. Not really parents, but you can have multiple interfaces. And the reason that this is an important distinction is you are definitively in Java only allowed to extend one class. So in all of the examples that we've drawn and that we've talked about, there was one parent. And that is the rule. You can only extend one parent. However, the other keyword that Java has is implements, and you can implement as many interfaces as you want. So you can actually do both. You can extend mammal and implement talkable, or implement walkable, or implement gatherable, or whatever other interfaces that you may have. You can have as many of them as you want. The camera has stopped tracking me for some reason. There we go. Okay. Hopefully it tracked me all the way over there. Anyway, so interfaces, very similar to abstract classes. They allow unrelated classes to share common methods. So what does that mean? Well, unrelated classes, you might have two separate classes in your code that have nothing to do with each other. You might have the weather, which is dealing with clouds and sky and rain and brightness and darkness, and then you might have another set of classes that deal with how the grass grows. And both of those have nothing to do with each other, sort of. I guess you need some amount of weather for the grass to grow, but you could have a common interface that they're both implementing because that makes sense. So it's possible for a bunch of unrelated classes not to inherit from the same parent, that really doesn't make a lot of sense, but for them to all implement the same methods because they are implementing the same interfaces. So the rules of an interface, all methods must be abstract. As a matter of fact, this is so much of a rule that you don't even have to write the word abstract in there. It's implicit. The fact that you're writing something in an interface means that all the methods are abstract. Also, you're not allowed to have a constructor, and that's simply because it doesn't really make sense to implement a constructor because you're never going to instantiate interfaces. Doesn't really make any sense. Interfaces are often named I followed by the name that they are, just so that you know that it's an interface. This is a convention that actually comes from C#, which we're going to look at the end of the semester. In C#, that's the convention is that all interfaces begin with a capital I. Java doesn't have that same thing, but it's not a terrible idea. So we're going to mention it now so you can kind of get used to it. Any class can implement multiple interfaces using a comma. You can't instantiate them, and interfaces can have attributes, but if you do that, they have to be declared and initialized at the same time. All right, so let's take an example. So we have our interface here. This is interface talkable, and what's happening here is that we have a single method, void talk. So that's inherently public and it's inherently abstract. It's public because everything in Java is public by default. It's abstract because we're in an interface. So notice the keyword here is interface, not class. All right, and then to use that interface, we have a class dog, and the class dog simply says implements interface. This is a new keyword. It is different than extends, which is what you're doing when you're actually inheriting from a class. In this case, you're not inheriting, you're implementing an interface. So the moment you say that you're implementing talkable, you must have a void talk because that's what the parent has. So here we have our public void talk, and it says wolf. It is declared as an override. It technically is an override. That keyword, again, is optional. You can put it there or not put it there. And now we are allowed to implement our dog. So we can have dog d equals new dog because we have successfully created the interface. And we're allowed to say d.talk because we know that the dog implemented talkable, therefore it has a talk method, and we can see it right here. So even without being able, even if I were somehow able to hide this code from you, the fact that you can see this code and this code guarantees that as long as the dog implemented talkable, it must have a talk method. And that's the beauty of interfaces, is that they allow you to see they require all of these methods to be created, much like an abstract class. All right, so the last rule, a class that implements an interface has a choice. Either it must actually declare concrete versions of all the methods, or it can declare itself abstract, just like we were talking with abstract classes. So it's possible for one class to not implement all of the methods and just pass it on to the child. And so here's an example of that. So we have our interface talkable, which still requires a talk method. And then we have an abstract class dog, which implements talkable. So the abstract class dog can have very many other methods. It could have methods for walking and all kinds of other things that the dog is able to do. But since it's declared abstract, it can choose whether to implement talkable or not. Now, if we do this, this class is no longer instantiable. So I'm no longer allowed to do that, which is dog d equals new dog, because it's no longer a concrete class. In order to be able to make an object of the dog, which I won't be able to do, I'd have to have a child class, so maybe class, let's call mutt, which extends dog, and then that class must have a void talk, which actually has code in it. That is void. That's the worst writing ever done on a computer screen. Anyway, so void talk has to be here, and there has to be actual code in here in order to satisfy the interface. Now I would be allowed to say mutt m equals new mutt, or for that matter, dog d equals new mutt. That's allowed, or even talkable t equals new mutt, which is a little bit confusing, but all of these abstract classes and interfaces are allowed to be used as types. So if I just clear my screen here for a moment, what I'm telling you is I can say talkable T, of course it can be anything, equals new dog. Mutt. Mutt was the name of my child class. I'm also allowed to say dog D equals new mutt. That's allowed. And I'm allowed to say mutt D, M, I guess, equals new mutt. All of these are allowed. So even though talkable is an interface, you can use it as a type for instantiating objects to do things polymorphically. And effectively, the reason you would do that is because I might want to create a collection of all of the talkable objects in the game. And then I might want them all to talk. If I needed something where every character simultaneously says something, I might create an array list of all the talkables and then ask all the talkables to actually talk. And I know they're all able to talk because they are talkables. So that's why we have this. All right, and so here we have interface talkable and interface consumer. These are two separate interfaces that have nothing to do with each other. And then this just shows the syntax for if you're implementing more than one interface. You can say implements talkable, comma, consumer. And you can have as many of these in here as you want before the curly brace. The rule is when you've got two, like these two, you have to implement both of the methods that were required. This one comes from here, and this one comes from here. So you get the sum of all of them have to be implemented. All right, so imagine you're using a video game, or you're implementing a video game, and it's a magical world with non-animate objects that come to life. How might you use interfaces here? So the idea here is you could have interfaces for, let's imagine you have a character in a game, and let's imagine that the character can walk in the beginning of the game, and then at some point they drink a potion, and all of a sudden they're able to fly. So in that circumstance, how does the character change? Well, at the time you create the character would be a child of walkable or a child of whatever it's a child of. And then at the point that it drinks the potion, you would simply make it so that it is now a child of the other interface. So you would redeclare it such that it is now a flyable, or whatever is the thing that the potion allows you to do. And so effectively what you would do is you have the original type, whatever that might be. So in the case of our characters, so we might have character which implements walkable. And then later you might have a flying character and it's going to extend character and implement flyable. Okay, so these two classes can coexist at the same time, and effectively what's going to happen is, so you created your character X equals new character. And character runs through the game and does all the things that character is supposed to do. And then character drinks a potion. You're going to simply say X equals new flyable flying character. Now, you're going to have to copy over all of the data from the old character into the new character. So any health points or any things that it's added to its item bag or any of those things, you'll have to manually move those over after you've created a new character, because this, of course, deletes the old one. This is now garbage as soon as you do this. So you would grab all of the information out of it, simply change yourself to the new flying character, and now you're able to proceed through the game, but you're actually able to fly instead of just being able to walk. And so that's why you would have interfaces. It's effectively, the rules of how you fly are all contained in this flyable interface, and as long as you implemented that interface when you made this character, it now knows how to fly. And changing from one type to the other is as simple as just changing the actual object. Okay, so in summary, we have interfaces, which are basically the same idea as abstract classes, except everything has to be abstract. That's really the only difference. They're pretty much how we get around the diamond of death problem that we had in all of the other languages, where we don't allow ourselves to have two parents. You can have two interfaces that you're implementing, and the rule is because they don't have implementations, you're not inheriting two conflicting answers. You're just inheriting a rule that says you must know how to run. They are very similar to abstract classes. A class implements an interface instead of extends an abstract class or extends a concrete class. So it's a new keyword, implements. And so we're just going to do a quick little bit of code over here just to look at this. I'm going to make a new interface. And we do that in here by clicking, well, we can just do the class. I'll call it walkable. I'm going to change it to interface. Public interface walkable. And then inside of here, I'm simply going to give it the various methods. So public void walk, public void run, and maybe it also knows how to void crawl. Okay, so anybody who's going to implement walkable must implement those things. I probably have a whole bunch of other stuff that I would want them to get, but I'll start off simple. So now I'm going to add a new class, and I'm going to call it character. And my class character is going to have a whole bunch of stuff. So it's going to have a size, and that really should be private, not public. And it's going to have a color. And maybe we keep track of whether it's evil. I don't know why, but every time I say evil, I hear Skeletor in my voice. Anyway, moving on. All right, so now it's going to have its capabilities. So if this character is going to be able to run or walk, then I'm going to say it implements walkable. The moment that I do that, it's going to get angry at me because now I have a whole bunch of methods that I have to do. Class character must either be declared abstract or must implement abstract method walk. So I have to have a public void walk, and that's not going to be sufficient because now it's also going to require me to have a public void run, and that's not going to be sufficient. I'm going to need a public void crawl. And the moment that I write that one, it stops being angry at me because now I've successfully met all of the requirements. Now, of course, all of these are empty, and that's probably not what you want. At this point, you would get fired if you turn in this code from your job because you did technically meet the interface, but of course you didn't actually write any of it, which is really not what you were paid for. So you definitely would go through and write all of the details of how walking works, how running works, how crawling works, and so on and so forth. And then meanwhile, there can be other people out there that are writing other classes at the same moment, which can either be children of your character class or they can be separate that also implement walkable. Maybe there is somebody out there who's writing the spider class, which is not really a character, it's just something that's, you know, crawling along on the ground. Well, maybe they also need to implement walkable, and so they'll implement it even though they're not a child of character, even though they're in a completely separate org chart in the company, in a completely different country that they're coding, they are writing the same thing because they're also implementing walkable. So somebody at the top level in the company writes out the walkable interface, and then it's up to all the developers to actually implement that. All right, so that completes our talk today on interfaces. Join us back in the next section where we're going to do a comprehensive example of everything that we've looked at in object-oriented. So I will see everybody there.